Hello class, welcome to lesson 6.5, Properties of Special Parallelograms. So the essential question we want to address today is what are the properties of rhombuses, rectangles, and squares, differentiate them from other parallelograms? We want to be able to use properties of these three special parallelograms to solve problems. So let's investigate a rhombus. We know that a rhombus is a parallelogram, but it's a parallelogram specifically with congruent sides. So each of the sides are the same length. It also has congruent opposite acute angles and congruent opposite obtuse angles. So that's generally what a rhombus is. So it usually has these sides are congruent, and then the opposite angles are congruent. But the angles next to each other are not necessarily equal to each other. All right, so let's call this rhombus ABCD, and let's investigate a property of the rhombus as it relates to its diagonals. So let's draw a diagonal through BD here and label the angles 1, 2, 3, and 4 that are made. So what we want to do is investigate 1 and 2 and 3 and 4 to see if they're congruent to each other or what other properties this has. So we want to prove that they're actually congruent to each other. So we're going to go about proving that 1 and 2 are congruent and 3 and 4 are congruent. So we know that this diagonal BD is congruent to itself by the reflexive property. And therefore, this triangle number 1 and triangle number 2 are congruent. Triangle ABD, triangle CDB are congruent by SSS, side, 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 side. And so they have to be congruent. Now that we established that they're congruent, then this means that angle 1 is congruent to angle 2 because they correspond to these triangles, right? So because the triangles are congruent, that means that their angles that correspond to each other must be congruent. So this is by the CPCTC, corresponding parts of congruent triangles are congruent. Similarly, angle 3 and angle 4 are congruent as well. Therefore, we can determine that the diagonal bisects the angles of a rhombus. And this is actually what we wanted to demonstrate here, this property. Let's demonstrate another property of a rhombus. Let's say suppose we have two diagonals this time. We want to show the relationship between the measures of 1, 2, 3, and 4. What we're going to do is we're going to prove that angles 1 through 4 are 90-degree angles. So we know by the converse of the perpendicular bisector theorem, if we look at vertex A, because it is the same distance from D as it is from A to B, it's the same distance, this means that A must be on a perpendicular bisector. In this case, the perpendicular bisector is AC. And therefore, if it's on a perpendicular bisector, that means it cuts this side in half, this line segment in half, and it's perpendicular to that line. And therefore, that proves that those are 90-degree angles by the converse of the perpendicular bisector theorem. And so, getting these marks out aside, we know that these are 90 degrees. And therefore, if 1 and 2 are 90-degree angles, this must mean that 3 and 4 are also 90-degree angles in the same way because it's a perpendicular bisector. All right, so since they are all right angles, that proves the property of the rhombus. So notice that the diagonals intersect at a 90-degree angle. So theorem 616 was the one that we first proved that stated that if we have a rhombus, the diagonals are perpendicular bisectors of each other. They're 90-degree angles. This is actually the one that we just proved. And the bottom one is theorem 617, which is the one that we proved earlier as well. And it's that the angles here are congruent, that it bisects the angle in half. All right, so let's look at our first example. What is WY? In this example, this is a rhombus because we know that we have the sides are congruent here. So if this is 5, that means these are all 5. And because this is a rhombus, we know that x, z, w, y are perpendicular. That's one of the properties that we proved earlier. And so that means that, and also if this is 3, then this has to be 3 over here. And so you can see that we have a right triangle here. And so we can use that to find the length of this side. So using this right triangle here, I'll redraw it here just for emphasis, so we can kind of just focus on it. We can use the Pythagorean theorem to solve this right triangle for the missing side A. Remember, a squared plus b squared equals c squared. And so we have a squared plus, in this case, 3 squared is equal to the longest side of the right triangle, 5 squared. So we have a squared plus 3 times 3 is 9, 5 times 5 is 25. Then we can subtract 9 on both sides. So we have a squared equals 16. Take the square root of both sides. The square root of 16 is 4. So we know that this missing side is 4. So I will replace this with 4. And therefore this part has to be 4 as well. So the entire length of WY is 4 plus 4, which is 2. Or which is 8 rather. I said 2. It's 4 times 2, which is 8. Okay, so for the measure of RPS, we're looking for this angle here. Now we know that one of the properties stated was that if you have a diagonal, it cuts the angle in half. So whatever this angle is, this angle has to be the same. And we know that this is 70 degrees, and therefore this has to be 70 degrees. And because opposite angles are congruent, and we also know that because the opposite angles are congruent, then these must be congruent, and they must be congruent to each other. So I'm going to call these two angles x, these two angles x, and we know that in a, and we can just focus on one triangle. We don't have to focus on all these triangles. In fact, I'm just going to focus on those triangles there. If we look at just the one triangle, we know that the angles in a triangle add up to 180. So we can do 70 plus x equals 180, and then we can solve for x here. So we get 70 plus 2x equals 180. We'll subtract 70 on both sides. So we got 2x equals 110. Dividing by 2 on both sides gives us x equals 55. So therefore, angle RPS is equal to 55 degrees. All right, so let's look at example 2. Going straight into it, we have ADE is this angle right here. So we're trying to figure out that angle. But we know that this angle has to be 90 for a rhombus. So we're going to go ahead and label that a 90-degree angle. And so we have these two angles here, and we can find this angle. So this angle, if we use this triangle, is going to help us find this missing angle, which I'll call x. So we know that in a triangle, the angles add up to 180. So we have x plus 53 plus 90 equals 180. We'll do the math here. We got 143 equals 180. Subtract 143 on both sides, and you're going to get x is 37 degrees. So this here is 37, which means that because opposite angles are congruent, this is also 37. So the answer here is that this is 37 degrees. Let's find HL here. We know that in a rhombus that the diagonals here on either, so the diagonals cut each other in half. So this half is equal to this half. So therefore we can set these equal to each other, and that'll help give us what x is. Okay, so we're going to set those equal to each other, and that'll help us solve for x. So we have here, let's go ahead and subtract 2x on both sides. We'll solve for x here. 3 equals 2x minus 7. We'll add the 7 to both sides. So 10 equals 2x, which means x is equal to 5. 5 times 2 is 10. So we got x. We're going to plug it in here and see what we get. And we're going to plug it in here as well. We might as well plug it in there. So if we do this here, we get 4 times 5 minus 7, which is 13. So I'm just going to call this 13. And if we plug in x here, we're going to get 3 times 5 plus 1, which is 16. So I'm going to go ahead and call this 16 instead. So we know that diagonals in a rhombus form a right angle. So I'm going to focus on doing this right angle right here. So this is my right angle. And so we have a right triangle here. Since we got a right triangle, we can actually solve for the missing side here. We'll call this side A. Okay, so let's redraw that right triangle just to show you. We have A, we have 13, and we have 16. So we can solve for A here. So let's go ahead and do that. We'll do that over here. So we got, just for the sake of space, we'll do it over here. So we get A squared plus 13 squared equals 16 squared. A squared, 13 times 13 is 169. 16 times 16, 256. We'll go ahead and subtract those together. And you get A squared equals 87. Want to double check the numbers here. And so then A is the square root of 87. Okay, so we can go ahead and replace this with square root of 87. So HL is equal to that number. That's going to be some kind of weird decimal. I'm just going to leave it like this, although I'm sure you can simplify it in some way. Now that I think about it, I can't see a way to simplify it. So I'm going to leave it like that, square root of 87. Okay, going straight to another example, just to kind of give you an idea of how rhombuses work. We got a measure of angle MNO. So we know, again, that this is a 90-degree angle. So this is also 90. And we are looking for this angle right here, this total angle MNO. But we can find this angle if we know this angle. Okay, so first off, since we're trying to look for this angle, we can find this angle because we got a right triangle here. So let's go ahead and use that to our advantage. Okay, so let's use that right triangle to our advantage. Let's call this x. So you have x plus 62 plus the 90-degree angle equals 180. If we add these two together, you're going to get 152. And so x, subtract that on both sides, we get 28 degrees. So we're going to replace this now with 28 degrees. Okay, so we know that that's 28, which means that this is 28 degrees as well. And this is also 28 degrees because remember that the diagonals cut the angle in half, so it's the same on both sides. So this is also 28. So then if I add those two angles, that'll give me MNO. So the angle MNO is 28 times 2, or 56 degrees. Finishing up this last one, for example 3, we got QT. We're looking for this one right there. However, we got the whole thing here. We know that this is a right angle, which means all of these are right angles. We also know that this is supposed to be a rhombus. So we know that whatever this side is, it's going to be the same as that side. So we can use that to solve for y. So we had 3y minus 1 equals 2y plus 3. Subtract 2y. So y has to be 4 since 4 minus 1 is 3. Next, we can plug this in here. 5 times 4 minus 4 is 16. Which means that this has to be 8, this has to be 8, since the diagonals get cut in half. And therefore, QT is equal to 8. All right, so now let's focus on the rectangle. So we talked about the rhombus and its properties. We went ahead and proved some of those properties, and then we went over a few examples. Now, a rectangle is a parallelogram as well, but it has congruent diagonals and right angles. So unlike the rhombus, the angles on the inside are not necessarily a right angle. Now, they could be, like for example, a square is a specific type of a rhombus, right? But a rhombus is not a square in general. So, but in this case, a rectangle has 90 degrees, kind of like a square, but the sides need not be congruent, right? So the opposite sides are congruent, but the sides, all four sides are not necessarily congruent. Now, the important property here is that these diagonals have to be congruent for a rectangle, unlike for the rhombus. For the rhombus, you may recall that the diagonals are not necessarily the same length. So in this case, for the diagonal, this diagonal here is actually longer than this one. So in general, they're not the same length. They're only the same length, for example, in a rectangle. They're also the same length for a square. So a square is a rectangle with congruent sides and also congruent angles. A square has properties of a rectangle and a rhombus. So let's demonstrate this here. We know that a rhombus has a 90-degree angle where the diagonals meet. The diagonals get cut in half, but they're not the same length. So therefore, I put different amounts of tick marks here. And the angles get cut in half for a rhombus. Now for a rectangle, the diagonals are the same length, and therefore all four of these line segments are the same length. This angle is not a right angle in general. Whereas a square takes the right angle property from the rhombus right there, but a square also takes the fact that the diagonals are the same length from a rectangle. So you can see that a square has properties of a rectangle and a rhombus. And in addition, the angles in the square get cut in half. So that's another property of the rhombus that the square has. So in general, we can say using this diagram that a square is a rhombus and a square is also a rectangle. So a square has a rhombus property, and therefore it is a rhombus. A square has a rectangle property, and therefore it is a rectangle. But a rectangle is not a square because a rectangle does not have the rhombus property. And a rhombus is not a square because a rhombus does not have the rectangle property. Okay, so let's look at example 4. Find each length and angle for a given rectangle. Round to the nearest 10. Okay, so we're looking for GHK, this angle here. We know that these are all right angles. So we know that this is a right angle, for instance. So we know that since this is a right angle, and we know this angle here, that means we know this angle here. Okay, so this angle here has to be 38 degrees. 38 degrees plus 58 is 90. Okay, so we know that much there. And we also know that opposite angles are congruent in a parallelogram. So if this is 38, well, this has to be 38. I know the bottom one has to be 38 because alternate interior angles. Remember that in this case, these are parallel. This is my transversal. Alternate interior angles are congruent. And so that's 38, and this is actually 52. So just be careful with that labeling. Okay, so now the next important part is here. Because we know that this is a rectangle, we know that these are congruent and these are congruent. Now, if I focus on this, notice that this is an isosceles triangle. By the isosceles triangle theorem, we know that if we have an isosceles triangle, that means the angles opposite have to be the same. They're congruent. So that means if this is 38, this has to be 38. So by the isosceles triangle theorem, we know that this has to be 38 degrees. So therefore, GHK is equal to 38. Similarly, if I focus on this isosceles triangle, then this is 52. So in this case, HLJ is going to be this angle. So we can focus on this right triangle here, or this triangle rather. And we know that those two are 52 degrees. So we have 52, 52, and X. Remember, we know that the angles in a triangle add up to 180. So let's go ahead and use that to our advantage. 52 plus 52 is 104. So that means if I subtract 104 from 180, X has to be 76 degrees. All right, let's erase this for a second. Focus on GJ. So we're looking for this one. We know this is 10, so this is 10. We know that's 7, so this is 7. We also know, let's see, we also know that these are congruent. So we also know one thing here. We know that this is a right triangle. So we can use this right triangle and use the Pythagorean theorem, and that will give us GJ. So you can hopefully see this right triangle here, 10 and 7, and we'll call this C. So we'll use a Pythagorean theorem and say C squared equals A squared plus B squared. So we got C squared equals 49 plus 100. So C squared equals 149. And the square root of 149 is not a nice number. So I'm just going to leave it as square root of 149. Okay, so this here is square root of 149. It does say round to the nearest tenth, so we'll go ahead and get that to a decimal. That's going to be about 12.2. Okay, so now let's find HL. That's pretty easy because we know that this diagonal is the same as this diagonal. And so HL, notice, is half of the diagonal. So we're just going to cut it in half. So it's going to be half of square root of 149. So square root of 149 divided by 2. And we'll get that as a calculator number here. So that's about 6.1. All right, so now let's look at a square. Find each length and angle measure for the square. Round to the nearest tenth. So we're looking for SV. So to find SV, well, we know that this is a square, so all of these are the same dimensions. So this is 4, 4, 4, and 4. We know that for a square, we have right angles. So let's use this right triangle here, and we'll use the Pythagorean theorem to get C, the hypotenuse. So C squared equals 4 squared plus 4 squared. C squared equals 16 plus 16. C squared equals 32. And then we can take the square root of 32, and that's going to be 5.7. Now, because we got to take half of this, so this is about 5. This is square root of 32, and this is square root of 32. So that means, or rather, the whole thing is square root of 32. I meant, so this whole thing is square root of 32, which means that this right here is half of square root of 32, and this here is half of square root of 32. So we're going to have to, so SV is half of it. So let's get that as a decimal number, which is about 2.8. Now we got RT, but RT is pretty straightforward because we already know that this whole thing is square root of 32, which means that this whole thing is also square root of 32. So that's it for RT, which is approximately 5.7. Now we'll do the perimeter. The perimeter is pretty straightforward as well. We have R, V. So we're focusing on R, V, S. So this is 4. and this is square root of 32 over 2, rather, and this is square root of 32 over 2. So we just, to do the perimeter, we have to add all these sides of this triangle. So we have 4 plus square root of 32 over 2 plus square root of 32 over 2, and we'll get that number. And that's about 9.7. All right, that's going to do it for the video, guys. I hope you took a few things from this video. I hope you learned something. As usual, I'll see you in the next one.